Hi, Lee. I hope you're doing well. So my lesson is going to be on piano curves and what they are, and I'm going to touch upon Hilbert curves as well a little bit. So the purpose of this lecture is to be able to understand what piano curves are and Hilbert curves are and how to make them on your own, learning why they are important and why they exist, and then also understanding why piano curves are considered to be counterintuitive. So this is just a quick overview. We're going to be doing an overview of piano curves, significance of piano curves, talking about if they're theoretical or applied math, and then we're going to finish off with some concluding remarks. So first off, what is a piano curve? A piano curve is considered to be a continuous function from the unit interval onto the unit square. It was discovered in 1890 by Giuseppe Piano, who we will learn a little bit more about in just a minute. And then most importantly, piano curves, as well as Hilbert curves, are considered to be space-filling curves. And we will see what that looks like in a little bit too. So just a little bit of background. On the left-hand side, we have Giuseppe Piano. He came up with piano curves in 1890, while David Hilbert created Hilbert curves in 1891. So we are first going to talk about how to create a piano curve. So starting with n equals 1, we are going to split this image into 9 different subsections. So it's going to look like this. And then we're going to imagine that we're in a grocery store looking for a couple specific things. Maybe we're trying to make chicken Alfredo. So we're going to start in this aisle of the grocery store. We're going to start with the pasta. Let's see what pasta we want. Then we're going to look into the next aisle. We're going to look for the pasta sauce. And I know usually they're in the same row, but for understanding's sake, the pasta sauce is going to be in this next aisle. And then we want to get the chicken. So the chicken is going to be in this next aisle. So that's how we want to think of piano curves. Starting in one aisle, going to the next, and then finishing off in a different aisle. So this is where n equals 2. So we're going to try to create this as well. So we're going to also split the square into 9 different subsections. Then we are also going to split each of these squares into 9 different subsections. So we're doing that here. All right, and then this bottom left yellow square represents one piano curve. These green circles on this represent the one piano curve, connecting to another piano curve, connecting to another piano curve. As we can see, this is continuous throughout the entire square. So again, we're going to the grocery store, looking for a pasta. We're looking for a pasta sauce in this next aisle, and then the chicken in this aisle. So we're starting in one aisle, going to a next to find our pasta sauce, and then we're finishing off in a different aisle. So that's also how we want to think of that n equals 2 piano curve. This is what n equals 3 looks like. We're not going to get too much into how to create this just for time's sake. But as we can see, as n gets greater, the amount of space that gets filled gets greater. Now quickly looking at Hilbert curves, we're going to look at how to create pseudo-orders 1 and 2. And then we will talk a little bit more about why they're important. So how to create a Hilbert curve. So we're going to start with the square. We're going to divide it into 4. And then we're going to start with the line here, and we're going to end up in here. We're going to do the same crossing into this square, and then we're going to do the same crossing into the bottom right square. So that is pseudo-order 1. The next thing we're going to do is we're going to do a pseudo-order 2. So we're going to first split it into 4, and then each of those we're going to split into 4 too, like this. And then we're going to draw our Hilbert curves. All right, and now we want to connect them. But as we can see, these two connections here are overlapping. We don't want the lines to overlap. So what we're going to do is we're going to get these 2 green circles, and we're going to flip them so that there is no overlap. So that is going to look like this. This is where the green circles ended up. All right, so we looked at pseudo-orders 1 and 2, and then this is 3, 4, 5, and 6. And similar to piano curves, as we can see, as n gets greater, so does the amount of space that's filled. So what's the difference? Peano curves are more of an arithmetic analysis approach. Arithmetic sequences is when you add a constant number every time. So in this case, we added a constant number by 1. For the Hilbert geometric approach, we multiplied a constant rather than adding. And in this case, for Hilbert curves, we did it by 4. So that's just the general difference. So why are they considered to be counterintuitive? Counterintuitive means an outcome that is different than what you expected. So they are thought to be counterintuitive because how could this line of 0 thickness, just about, fill up the entire space in this small square, in here and here? So that's why there's a misconception of the counterintuitive of Peano curves, and then Hilbert curves also apply to that. So why do they exist? They continuously map multidimensional space into a one-dimensional space, and they are also part of the Lindenmar system. They're used for multidimensional indexing, advanced coding, and generating realistic images, as well as other things that we won't get into today, but that's just some of the things that they're useful for today. Peano curves, so are they theoretical or applied? So theoretical is when we're proving a theory, and applied is when we're more problem solving. So there is no right or wrong answer, but in this case, they are more so applied just because Peano and Hilbert did most of the theoretical aspect of these types of curves. This is just a quote on how important it is to understand math. Just to check in if you understand how to do these things from the lecture, some resources, and my references. Okay, thank you so much for listening.